Okay, so suppose Frida's, Bert's, and Don's houses were at different locations. You can generalize their locations by using x1, x2, y1, and y2 and still solve for the distances between their houses, right? So this is really x sub 1, y sub 1. These little subscripts just mean the first x value. This just means the second x value. So Frida lives this far from Bert, right? And they live at the same y coordinate. Don lives at different y coordinates from Bert, but they live at the same x coordinate. Okay, use the graph to determine the distance from Don's house to Bert's house. So remember, Don's house, they same x coordinate, but y2 minus y1. Y sub 2 minus y sub 1 is how far apart they live. You have to subtract their y values, right? But between Bert's and Frida's house, remember, you have to subtract their x values because they live at the same y coordinate. So x sub 2 minus x sub 1. And again, reminder, these are not exponents. They're not operations. They're just a way of saying the first x value, the second x value. So take the second x value, subtract the first x value, you have the distance. Okay. Now use the Pythagorean theorem to determine the distance from Don's house to Frida's house. So that's, again, on that, you can see this kind of down here. That's on from here to here, that distance. So remember, this leg is x sub 2 minus x sub 1. So we've got one leg of the triangle is this long. We've got another leg of the triangle as this long. And if we square this and add this, right? This should equal the distance from Don's house to Frida's house. They're calling that df squared. So if you take the second x value, subtract the first one, square it. Second y value, subtract the first one, square it. You should get the hypotenuse. Remember, that's the hypotenuse squared. So this is called the distance formula. And it looks very complicated. It's kind of complicated to figure all this out. But when you're looking at it on a picture, it's not all that complicated, right? When we were doing it with Don and Frida's houses with real numbers, it's just about finding how long this is, finding how long this is, and then using the Pythagorean theorem to find out how long that is. So the distance formula says basically if you need to find any 2 points, you can plug it into this formula, or you can just use your common sense to use the Pythagorean theorem. So here they're asking, do you think that it matters which point you identify as x sub 1, y sub 1, and which point? Do you think it really matters which one you identify where? And so I want you to think about that and answer it. Does it really matter whether we call this the second point or this the second point? Think about that and answer that question for yourself. And here, there's 3 problems where you have to actually calculate the distance between these 3 points. So let's plot them. Let's plot 1, 2, and then 3, 1, 2, 3. Wow, I didn't really leave myself enough room there. So I actually think I'm going to just plot it on graph paper so that it's a little bit easier to see. Okay, so 1, 2, right? And then 4, 5, 6, 7, and then 1, 2, 3, and 7. So those are the 2 points they want us to find the distance between. Now, I don't technically have to draw them. I could just use the distance formula if you feel comfortable doing that. But I personally think it's just so much easier just to draw it out and see it. So I'm talking about how far apart these 2 things are, right? And again, you can plug it into the distance formula, but I just think it's easier to see it worked out with Pythagorean theorem, right? This makes a right triangle. So this is 2 long here, and this is 1, 2, 3, 4, 5 long there. So I just need to use the Pythagorean theorem. 2 squared plus 5 squared equals c squared. We don't know how long this is, and that's what we want to know how long it is. So that's 4 plus 25 equals c squared. So 29 equals c squared, and then if you take the square root of both sides, c equals the square root of 29. And it says round your answer to the nearest tenth if necessary. So let's put square root of 29 in the calculator. Square root is this blue right above the x squared button. So second x squared, square root 29, 5.4, rounded to the nearest tenth. So C is approximately 5.4 long. Right? So you should be able to do these two. I highly recommend you plot it on a graph paper, figure out one side, figure out the other, and then use your Pythagorean theorem, which is review. So question number 13 and question number 14. Carlos and Mandy just completed questions 12, parts A through C, and they needed to calculate the distance between these two. They noticed a similarity between this problem and part A. So notice part A is +1, +2, +3, +7. Here it's just -1, -2, -3, -7, right? Carlos says the solution must be the negative of a solution in part A. Mandy disagrees and says the solution will be the same. Who is correct? So I want you to think through this question and answer it yourself. You should be able to decide. Go ahead and plot these points and see what you think will happen. Is Carlos right? Should the answer about how far apart these are be negative? Or is Mandy right? They should be the same. So think about what you think and answer that. And now for number 14. Here is a distance where it's 5 units, and you want to use the distance unit. So we don't know where this point is. So this is a little bit backwards, and this is where you really need the distance formula. We're not sure how to plot this point. We know that one point is at 0, 6, right? So we can plot that. We can make another plot. And 0, 6 is 1, 2, 3, 4, 5, 6. 6 right here. So we know one point is right here. We know the other point is like at x, at some x value, and then 2. So we know that it's 2 up, but we don't know where it's at. It's somewhere on this line. Somewhere on that line. But we know that it's 5 units away. We know that it's 5 units away from here. So interestingly enough, notice that maybe it's this way and maybe it's this way. We're not really sure, right? Could be 5 units away this way, and it could be 5 units away this way. Now, we can maybe use, again, paper if we marked off units. 1, 2, 3, 4, 5. 5 units. And then just kind of matched it up. So 1, 2, 3, 4, oh, that's not 5. 1, 2, 3, 4, 5. So if we matched it up, that would match out to here, right? If we went from this point to this point, that's 1, 2, 3, 4, 5. So it looks like it could be here, or it could be from here to here, right? So somewhere around here, somewhere around either +4 or -4, right? So it looks like just from using our scale right here, x is going to have to be +4 or -4. Okay, now that's a way to plot it and reason through. But if we're going to use a distance formula, that's a little different. A distance formula, again, that distance formula is the second x minus the first x squared plus the second y minus the first y squared, and that equals the square of the distance, right? Okay, so we can just plug things in and solve. That's another way to do it. So this involves visual reasoning. What I just did there is using visual reasoning. This uses algebraic reasoning. We have a formula, we can plug things in, and we can find the answer. So I'm going to plug in, I'm going to call this the first point, and this the second, right? So I can just plug things in. My second x is 0, minus my first x, which is just x, squared plus my second y is 6 minus my first y is 2, and I'm going to square it, equals the distance, and that's 5, squared. So now I have an algebraic equation, right? So I can start simplifying. 0 minus anything is just itself, right? So what we really have in here is a negative x squared plus 4 squared equals 25, right? And then a negative times a negative is really a positive, so I can just turn this into x squared plus 16 equals 25. And then I subtract 16 from both sides. I get x squared equals 9. And then take the square root of both sides, and x equals 3. Now notice that really technically, when I'm taking the square root, I usually only see a positive, but I really should say or negative 3, because negative 3 times negative 3 could give me 9. And that's where you get that visual. It could be on either side. Now notice, I got a different answer than when I did this. And you know why? It's because here, this method was not as accurate. Marking the tick marks off, it turns out that I wasn't as accurate. You see that I didn't match them up very well, and that this should really have been a 3. So that's the problem with kind of using a visual estimation. It's easier, it makes more sense when you use the visual estimation, but it's not as accurate. Using the algebraic formula is the more accurate way. So it's actually 3 or negative 3, and I just overestimated how far that was. That was like an error of physicality. So that's the benefit to using algebra, is that it can be exact and it doesn't leave room for human error in estimation. So it's not really 4 or negative 4, it's 3 or negative 3, but hopefully you can see why the sense behind this with the picture.